I write a compiler for a small imperative programming language that I call Elna. The compiler is self-hosted, so it is written in itself, but it isn't finished yet, so there are a lot of things that are still not implemented, and therefore I cannot use them in the compiler itself, but I implement new features step by step, and today I will begin with looking at the function that is called Elna instruction list concatenate. This function is used once, but actually it shouldn't be used, I think, because recently I updated my list implementation. Before that I had a simple singly linked list where each element only points to the next element, but now I have a singly linked list as well, but there is a structure that contains the list, and this structure has a pointer to the first and to the last element, so that I can iterate list fastly and also append new elements. So this function is used in the allocation pass. I will split the screen, and here I will remain in this function, so I see how it is used. And we want to look what is RTL declaration, and RTL declaration is an Elna RTL procedure. And its body is already an Elna list. Here I create a new instruction. And then I say so we get a tail declaration here. And I actually append the first instruction of the body to the next element of this instruction, create result. And here we iterate through all the instructions, and it can already break the list if I append new instructions to the first one, not to the first. If I append new instruction to the last instructions, then the last point in the body won't point to the last instruction anymore. So this is actually not that fine. Alloc instruction and it accepts Elna RTL instruction. It would be better if it would accept the whole list, probably. instruction just has the next point operator on top runs. So let us call it instruction and let this be an ELNA list. And then we can pass, we can dereference the list and pass the first element to the instruction. And here I should then fix it to pass the pointer to the list. And we probably need a new local variable as a replacement for this instruction variable. And at the beginning we assign the first instruction in the list to this instruction variable. And then it should actually work, and here we pass just the current instruction to this function, and then we go to the next instruction. So after that we go to this ELNA alloc instruction function. And this function can actually insert new instructions into the list. So we will need pass the instruction that we are currently looking at, as well as the list itself, so we can handle it properly. And I think that we can just create a new variable in a list. And we can pass the pointer what is alt instruction here? Is it used? Yes. And I make, for example, this copy in here. Here we can just call this function as well. Then we have only one line instead of 3. We set the first operand and this instruction operands to kind, instruction operands to value, and instruction operands to length. And it just allocates a pseudo variable and loads a value. Here we have the same. And we just set it directly on the variable we are looking at. And I do not add new instructions or set next values, so this should be fine. Then we have this elna alloc part address. This gets an instruction and just changes its operands. Okay, and this elna alloc operation target. Exactly, this one adds new instructions to the list. Here, for example. So it is called from also the slot address function, so we need to pass the list to this function. Yeah, this is actually fine, and it isn't used anywhere else. And then we can check whether it compiles. And now we can pass it further. So we can look at this alloc operation target. I want to just see where it is used else. So it is used in this lot address, and then in this instruction function itself. And it isn't used anywhere else, so we just add an elna list as argument, and then instructions here. what I actually do here, I create this store instruction and I insert it into the list after the current instruction. And this thing, we want to extract this logic into a separate function. So let us find the list functions, for example, with append. And after this one, we will create a new procedure, insert after. It will get the list as argument, then an existing element, and a list node, and then a new element. We can just call it new, I think. And this will have actually the same logic. So the next element of the new element is then the next element of the existing element. So basically we say that new next is existing next. This is the first step. Then we allocate a new variable, we do not need it, and set the operands. And after that we assign to the next element of the existing instruction existing. We assign the new instruction basically. And that's it actually. And the one thing that we need to look at, if the existing instruction is the last instruction, then we have to update the last element of the list. Let me compile this first. I haven't implemented error checking yet. Therefore, I compile the compile itself very often just to be sure that I haven't missed something, a semicolon, or just haven't added some mistake or something like this. So if existing next is nil, then we set the last element of the list to new. This should be the logic. I still need to assign the next element, or probably not. I can just assume that the next element of this new, that this is just that the next element of this new element, that this is nil, then I do not have to set this to nil. I think that functions that create these operands, like this instruction create, that they actually set next to nil. Yes, they do. So I can just do it in an else condition and write it like this. I always need to set the new element as the next element of an existing element, but I only need to set the next element of the new element if it isn't nil. Okay, that looks fine. So how can we use it here? We just create an instruction. We don't modify the next element manually. We allocate a variable and we set the operands of the new instruction, and we modify the current instruction itself, and then I can insert into the list instructions. Existing element would be just instruction. I think it is LNRTL instruction, so it is a list node, and the store instruction is the instruction that we do insert here. Okay, that actually looks fine. So we can remove these comments from here and probably just rearrange the new lines, and that should be fine. So this is elna alloc operation target, and then it is used from here, and here we just modify the existing instruction. That's fine. This one does the same, but it probably inserts an instruction not after the given instruction, but before it. and this will be more difficult since we do not have a reference to the previous element, so we cannot just adjust the next pointer, but we can replace the current element with a new element and then update the list pointers. So, what is the task? We get an existing element and a new element. I actually cannot just copy the elements. It won't work because I do not know their real size. List node is just the basic type, but I do not know what additional fields does it contain. So we cannot probably implement something like this. We need a double linked list. So I create a new instruction here, and I copy my actual instruction into this old instruction. Then I update the instruction as I need, and I make this alt instruction, put this copied instruction after the updated instruction. And I know that both instructions are actually this branch equals 0. So but I update this instruction to be this lot word instruction. So I'm going to remove this one. We cannot implement it. With the current list implementation, and I actually do not want to move to doubly linked lists. Alt instruction is actually has two operands as well, I think. The one of them being a symbol and the other one is a register then. Can I just create this alt instruction so that I say that I want an instruction create, and the instruction I want to create is branch then equals 0. And then I want to set the first operand to T0 and I want to set the second operand to the values provided by the existing instruction. That will be instruction kind. I actually know from the second operand of this instruction, I actually know that the first operand is a pseudo register, but I do not know the second one. So we just say that this would be the second operand kind, and then we would have or we can just create a function that that copies an instruction. It would be also a possible way, I think, and it would be a bit easier. But here we reassign one operand anyway, so why shouldn't we just assign the second operand? So we take the value, it wasn't value, I think, no, value and length from the second operand, then we have a finished instruction, and we do not need this memcpi anymore, I think. Can I just remove it? No. So something is missing. I create an instruction and I set it kind, value and length, the second operand. The next element won't be set. This is probably the reason, because alt instruction copies the next element, so temporarily we want to copy also the next element from the instruction. And just try again to remove these two lines. Okay, that looks better. Exactly. After that, we allocate a pseudo variable and we update the instruction to a different instruction kind. That is fine. I probably do not need this line anymore because we do it above. exactly, and actually that's it. So we can remove this, and then I just say that I want to Elna list insert after, and I pass the list to it, and the existing element is again an instruction, and we insert our old instruction, and I should actually rename this variable. Exactly after this instruction, and it shouldn't be needed anymore to update this next pointer. Okay, that looks fine as well. So we can remove this stuff, and we can remove this one. And here we just set the instruction basically. Show. Okay, this should be fine. Is this alt instruction used anywhere else? I do not think so. So let us rename it into the new instruction. Oops. I also do not need these go-tos really. So Elna alloc instruction end. There are a few places where they are used, basically only these two, and these go-tos can be just replaced with else if, I think. So we can remove this one. And we can also replace this with an else if. And also remove these two go-tos. And then I can also remove the label. So now we can quickly look at other functions, whether we can probably improve some other places. For example, this alloc load looks interesting. So this is this function, and it actually does the same, so it works with this alt instruction. And it actually does the same thing that it completely. So it is a store instruction, store word, and it basically does the same thing that it completely. It copies the instruction into the alt instruction, but just sets the operands anyway on the old instruction, so we do not really need this copy because we reset the operands that matter anyway. I'm not really sure what instruction do I handle. So my instruction is, I do not know what is my instruction. So we can just say that alt instruction is elna rtl instruction create, and we create the same instruction operator. Actually, I probably know it. Wait. So this is this elna allocate, and this is the only place where it is called, and it is only called if the operator is load word. So what we are going to do, we allocate a load word instruction, and after that, the same as before, temporary, we just set alt instruction next to nil, I suppose. No, to the instruction that we copy to instruction next. Exactly. So for this stuff, I do actually need this temporary variable, so I can move the allocation before I create this instruction. It shouldn't break anything, I think. And so load word, we have this pseudo thing, and I can just copy these two set operand functions or function calls. That should be fine as is. And I wonder now what would happen if I wouldn't allocate the memory here. The operator, the operator is actually not load words but store word. So we do it like this, and actually we do not need this, or I just put the comment here. And this already looks fine, so we can remove here everything, and I just set the operand on the existing instruction, and I set the old instruction as the next instruction to the instruction. That means that I can call my list insert. We can actually rename insert after into just insert, because there are not that many possibilities. Exactly, so we pass the instructions to it, the instruction and the alt instruction then. Then theoretically I do not need these two lines. Instruction and alt instruction. Okay, this is the state where it compiles, but I should be able just to remove it. Yes. What is the next? Exactly, we wanted to remove. I removed also the elna insert call, elna list insert after, but why it fails? Oops. Okay. And we pass or it is, we do not pass the instructions variable. Now I see what is my problem. So of course we do not, we do need the list itself. So the instructions list, and it is an elna list, and we pass this list to the function, and then we pass the list to the insert function, and its arguments. So all instruction becomes the next element after the instruction. So we take instruction and then the alt instruction. Then we try once again. And it definitely looks better, so we can remove these two lines now. And here we actually do not replace the current instruction, so alt instruction is not alt instruction, it is actually the new instruction. Okay, so allocate, create new instruction, set the values, insert it after the current instruction. Actually, updating the current instruction can be done before we insert it into the list. And as I said, let us update this insert after, or rename this insert after procedure into insert. How do I write these documentation comments? I do not write any documentation comments, okay? Inserts a new element after an existing one into the given list. Appends new element to the end of the list. And now we can continue. So then we have this alloc store function, alloc store. This one is used once as well, and it also allocates a new instruction and inserts it into the list. So we do here the same operation. We pass this instruction list to this function and add it to the arguments. So this is an list pointer. So we update the instruction to a different instruction. Alt instruction is rtl instruction create, and the instruction operator, so this is alloc store. The instruction operator will be store word. So we can copy this one and insert it in here. For this alt instruction we get the operands. So we update the second operand, and we inherit the first operand from the original instruction. That would actually mean that we can copy this stuff here, and then we need one more call that copies the sets the first operand of the alt instruction to the first operand, I suppose. Yes, to the first operand of the current instruction. So it will be the first as well, and we pass the kind to it, and then the value and the length. Instruction, alt instructions, set operand. Oh, the member is called operands. Still not fine. So we allocate the instruction and then we reassign it anyway. Here's a semicolon is missing. Okay, that looks fine now, and the alt instruction next would be the same as current instruction next. So alt instruction next is instruction next, and then we can remove these 2 lines first. and then I update the current instruction that remains as is, and I actually update the second operand. This line shouldn't be needed anymore. If I remove it, it should still work, and it does. So instead of this function, we are going to say a list insert, and we insert into the instructions. After the instruction, the alt instruction, I suppose, yeah. And then we can remove this line, and actually also this one. Yeah, so this can be removed. This is fine. This line can be removed. And actually, I think that is it. Okay, this is alloc store. Or I do a final additional test. Then we have this alloc operation target, and I think that I already modified this one. Exactly. And it is used everywhere else. So we do not have other functions. This block is a bit long, and I want to put this if else statement into a separate function. So we create prods elna alloc move, I would say, begin end, and we just copy this stuff into the function. And we probably will need the list here. No, we do not need the instruction list here, only the current instruction. We can copy the type from here. Do I need the variable map here? Yes, I do. So we can just copy these two arguments and insert them in here. Then we use this pseudo symbol variable here. And that's it, as it seems. So can we compile it? Yes, it already looks fine. And that would mean that I can replace this stuff then. So allocation move and instruction and variable map. both local variables are probably used here. Yes, exactly. The pseudo symbol and also this new instruction. Well, I think that we updated the allocation path to use the new list structure, and I still need to look at this concatenate function. What we actually do here, we add two new instructions to the list. The one is this allocate stack instruction, and the other one is the return instruction. And we have, of course, already a procedure for appending, but not for the prepending. We can leave it as is or define a function. I actually not sure, but prepend is actually pretty simple, I think. So what does prepend do? Prepend will set the first element of the list to the element. Before that, if the first element of the list is already exists, if it does already exist, that we do not want just overwrite it, but if list first is not nil, then element next is list first, and it actually doesn't matter whether it is nil or not, because I do not care, I think. So I just say that, and then I set the element as the first element, and the last element only changes if the list was empty. So if list last is nil, then we assign the element to it, and that should be theoretically it. Okay, so here we create a new instruction, as I said, and this instruction is this stack instruction, and it has only one operand. So we just call list prepend, I do not need this prepend function. I could just add it at the beginning and then pass the stuff already with this instruction to the visitor. But it would then visit this prepend function. Yeah, we could solve it without prepend but whatever. So I already implemented it and we want to check whether it works. So I pass the RTL declaration body pointer to it. It is the instruction list, and then the instruction that I want to prepend is basically this stack instruction, and I think that I can then remove this line and then this one is also not needed. Yeah. Then we create this return instruction with one operand as well, and this one operand is the stack size, so that the instruction does know how much stack to allocate and deallocate at the end. And instead of this concatenate function, we can just call elna list append, and we pass the list to it. And the stack instruction. And then this goto is a loop, so we just jump here to the next declaration, to the next procedure, basically. And it compiles. That would mean that we can finally remove this function. This is elna allocate procedure, so I can remove this stuff. And that's it for today.